Two more identities. First, let's talk about cofunction. Cofunction is how you alternate from a sine-based function to a cosine, or vice versa, all the way through, from psi y, cos x. So I have up here something you don't have in your paper. Now this is our y-axis, this is our x-axis. Now for any random angle, doesn't matter what the angle is, I'm just going to draw a little dotted line out here and say that theta always starts from the x-axis and goes over. How would I alternate? Well, sine is a y-based, cosine is x-based, because psi y, cos x, tangent is y over x. Now, if I wanted to switch from sine to cosine, what I would have to do is, notice I'm switching from y to x, kind of like an inverse. You know how you swap x and y? Well, if this is my angle here, and I'm looking for sine, going this way, of some point, or whatever, if this is my theta, and I want to all of a sudden switch to cosine, well, what I would have to do is switch the axes, because I'm dealing with y here, now I'm doing with x. So instead of measuring from here, I would measure from here, because I'm swapping the axes here. So if I swap the axis, my new theta would be going from this direction. Now, what is this line here? If this is 0 in radians, this is equal, the y-axis is equal to pi over 2. So what's happened is, if I'm measuring sine from 0, it's the same thing as cosine going from here over, because I swap x and y, so now I can swap from the y to the x. And this would work for all the other ones. That's how you get cofunctions. It's like that. Now you don't have to have all this memorized. You can look in the formula chart for these. So you can see them, that cofunctions are, actually, take that back. It doesn't look like they're listed on there. So you would have to know your cosine, your cofunctions. Even and odd. You can look for these, but you'll see that these are not on there. Even and odd. Even and odd, if you remember, this is cofunction over here. Let me write that over. This is for cofunction. Now, as it relates to even and odd, or as they say, odd and even, what those mean, and I want to show you by graphs of parabolas and cubics. Cubic is an odd function. Odd means it rotates, or it flips over the origin. So anything in the first quadrant becomes a third quadrant. It rotates this way. If there was something over here, it would rotate down to the fourth, or flip over the origin. Odd is a reflection over the origin. Even means something like an even power. It reflects over the y-axis. So it goes this way. So what does that mean? If you have sine of a negative angle, so a negative theta means it's going downward instead of upward, so like this way. This right there would be a negative theta, it would be a negative angle. Sine of a negative angle is the same thing as negative of a positive. So the same angle, but if it were positive theta, whatever theta is, it's positive. Sine, since it's a y value, this is a positive y here. Sine is positive. This one is like a negative sine. That's why a negative sine is the same thing as sine with a negative angle. Okay, because the y's, one's positive and one's negative. When you come to cosine, notice this. If you did that negative angle in there, you get this point here on the x-axis. But if you had the positive angle, you get the same answer. That's why these are the same. It doesn't matter if cosine's negative or positive, it's always even. Whether you go downward or upward, you're going to have the same cosine. It's going to be the same x value. If you go downward, you're going to have a different y value. This would be a negative y. This would be a positive y. That's why these have the negative outside and one doesn't. Tangent, you'd have one y and one x, and that's why, according to this rule, the x doesn't change, but the y's would, and so it follows, it's odd, like this. Okay, so let's move on. If cosine is this value, find sine of this. This is in the cofunction form. All right, now one thing people will learn is we can kind of use some n-solves here to find x and plug it back in. That's kind of a shortcut. But really what I want to do is I want to get this in cofunction form. The cofunction form says that cosine of x is equal to sine, and remember they wrote it differently. It was pi over 2 minus x, like that. Now this isn't in that form. So I'm going to try to rewrite it in this form. This is the cofunction from the previous slide. that cosine, where is it? Oh, cosine is sine pi over 2 minus theta. So here's what I do. I need to first get this in the same form. So this is the same thing as negative pi over 2 and a positive x. Now I've gotten it in this order, but I want this to be a positive. So here's what I'm going to do. I'm going to factor out. I'm going to GCF. So now I'm doing a GCF here, and I'm pulling out a negative. If I pull out the negative, I now have pi over 2 minus x. So what did I do? I factored out the negative. Now you see how I have sign of negative out in the front? Now let's go back over. So this was to get it into cofunction form. That was the idea here. But now that I have this negative out in front, I'm going to go back and see that on even and odd, a sign with a negative in the front is the same thing as just a negative sign. So I could go over here, and according to even odd, sorry about this. So according to my odd even rules, this negative can be moved out front, and I can say this is the same thing as negative sine of simply pi over 2 minus x. Now what do we know this is equal to? According to cofunctions, sine of pi over 2 minus x is the same thing as cosine. So I can substitute this right here and say this is just simply cosine of x. The negative would fall down. So it'd be negative cosine x. So if I've given this to find this right there, that's the same thing as negative cosine. I know what cosine is. Cosine we have is negative 0.75. Then this negative falls. What do you do when you have two negatives? Two negatives become a positive. So sine of x minus pi over 2 would equal 0.75. We did all that just to come up with that answer. That's correct. But that's how you do it. Let's do this next one. We'll go a little quicker though. So here, again, this is not in cofunction form. So the first thing I have to do is get this in cofunction form. So I want to switch the order. So it's negative pi over 2 plus x. Because x was positive, the pi over 2 was negative. Now that's not quite in cofunction form yet. Because cofunction, you're supposed to have a positive pi over 2. So here's what I do. I factor out the negative. I GCF. That's what I did here. I've done the GCF. I've pulled out a negative. I divided each one of them by negative. It's kind of like reverse distribution. So that's what I did to get from this step to this step. I did GCF. That's supposed to be an arrow. It looked terrible. Let me try that again. To get from this step to that step, I did GCF. Now, to get here to the next step, what I'm going to do is the odd-even rule. And so go back. When we have a cosine with a negative angle, how does that affect my problem? Well, according to this, cosine with a negative angle does nothing. You can just eliminate the negative. So this is the same thing as cosine. You can just eliminate that negative. Cosine of pi over 2 minus x. This negative got canceled right there. Now that we've learned according to cofunction, and that's what comes next, is the cofunction. This right here is equal to sine x. And sine x we know is, last substitution, this is negative 0.75. That means cosine of x minus pi over 2 equals negative 0.75. That's my answer there. Now I have one for you to try.